All right, guys, if you thought that the last thing we did, which was simplifying trig expressions, if you thought that was awesome, wait till you see this. Now we're going to verify trig identities. Okay, this is going to rock. So it says verify the following identities. Now, notice what's different. What's different is that there's an equal sign here. Okay, so one thing I want you to remember is what are we trying to do? We're trying to show that these two sides are equal to each other. Okay, before we were just simplifying and kind of just hoping we figured out something that was simpler than what was given before. But now we want to make one side equal the other. So my one thing that's crazy important for you to remember is you're only working with one side of the equation. It doesn't matter which one, but only choose one. You know, anytime we have equations, we're like, what you do to one side, you do to the other, blah, blah, blah. But in this case, we're just verifying. So you're only manipulating one side of the equation and hoping that at the end that you can find a way to make them equal to each other. Okay, that's number one. Number two, you know, you can choose which side of the equation you work with, but then you need to stick with that side the rest of the time. As far as advice for that, you know, I would choose the side that is less simplified. You're probably thinking, what? For example, if I look at this example, like this right-hand side is definitely more simplified, which means I would work with this side. Okay, that would be my advice. Choose the more complicated side. Okay, note that these we assume are true, and you know we're just going to show that they are equal. So I'll do the first one, and then I'll kind of have you guys try some of the rest. So this first one, we have cosine squared of x minus sine squared of x equals 2 cosine squared of x minus 1. Okay, so in terms of like which one's more complicated, they're about the same, you know, but I'm just going to work with the left-hand side because I see that it has two trig functions, and I think I can do something with that. Okay. Well, right away I'm noticing that I have the sine squared of x, and that actually reminds me of the Pythagorean identity, which is 1 minus cosine squared of x. And I'm going to keep an equal sign following along with me, and I mean, it's kind of up to you if you want to keep writing this every step. Okay, so now I have, don't forget, I'm going to really be distributing this negative. So now I have 2 cosine squared of x plus negative 1 or minus 1, which is equal to this side. Okay, so I just verified that first identity. Okay, so let's have you guys try these next three on your own. At least do something to get started, and then I can kind of help you from there if you get stuck. Okay, so try this next one on your own. Go ahead. All right, you guys, so let's see how you did here. So for this first one, I started by writing cosine of x plus sine of x times, instead of tangent of x, I wrote this as sine of x over cosine of x. Then I got a common denominator by multiplying that one by cosine of x over cosine of x. So now I had cosine squared of x plus sine squared of x all over cosine of x. But then right away here, I'm like, well, that's just 1. So I have 1 over cosine of x, which is secant of x. Confirmed. Okay, so if you haven't yet tried both of these, make sure right now is a good time to put me on pause and do that. If you're prepared to check your answers, then here we go. For this one here, I'm going to start with this left-hand side. Okay, so I have 1 over sine of x minus sine of x, and I got a common denominator by multiplying it by sine of x over sine of x. So I got 1 minus sine of x squared all over sine of x. But 1 minus sine of x squared is cosine squared of x. Check. Also notice that in every single step, I'm still using this notation where I say equal, right? And then at the very last step, I show that the left-hand side equals the right-hand side. I would really like to see that in your work. All right, final one here. So now I'm sure a lot of us, if we were dogs, our ears would be raised right now because I have cosine of negative x and I have sine of negative x. So here's where we have to use our even and odd identities, right? Remember that cosine of negative x is the same thing as cosine of x, and sine of negative x is the same thing as negative sine of x, right? Even, odd. Cosine's even, sine is odd. Okay, so now this is doable. Next up, you guys will see in my work, I multiplied by the conjugate of my denominator. And when I do that, now I multiply this out in the denominator, which will be helpful. That 1 minus sine squared of x is cosine squared of x, which allows me to cancel things. And now I have 1 plus sine of x all over cosine. So if I split that up into two terms, I'm going to get 1 over cosine of x plus sine of x over cosine of x, which is secant of x plus tangent of x. Done. All right, so in conclusion, we are verifying trig identities. Make sure you only work with one side. You can multiply, factor, you can add or subtract fractions with the least common denominator, you could split a fraction into multiple terms, combine like terms, you can substitute identities. All right, great job. Hope this was as fun for you as it was for me.